Alright, so this video is going to be on Chapter 1, Section 2, and this is all about quantitative data and how we display them and what we can do with their graphs. So the first thing I want to talk about is just the way we can graph quantitative data. The first video was on categorical, and we found out that we could do bar graphs and pie charts. So for quantitative data, there's three types we can do. We can do a dot plot, a stem plot, or stem and leaf, and a histogram. So I want to kind of go through these three and make sure you understand how to graph these and what they look like. So the first one is a dot plot. So if you need to pause the video and take some time to write down the steps, that's fine. If you already know how to do them and you don't want to write them down, they're your notes. You can do with them what you want. So once you kind of read through those, I want you to attempt to draw a dot plot of the data I have there. So just pause the video and draw those in your notes. Alright, so now that you've drawn it, I want you to take a look at what I've got. You should have a horizontal axis right here. It should be labeled with numbers at the bottom. So I've got 0 to 8 because my lowest value is 0, my highest value is 8. And then I've got a label of what those numbers represent. Then each dot is a value of the variable. So each dot represents a piece of my data. And that's how you do a dot plot. Pretty simple. I would say that this is the easiest way to display your quantitative data. The next one is a stem plot. Okay, this is kind of going way back to middle school on how to graph these. One thing I do want to point out that the leaf of your stem plot should always be the final digit. So if you have a 2-digit number, your stem will be the tens place and your leaf will be the ones place. If you have a 3-digit number, then the hundreds and tens will be your stem and the leaf will be still your ones place. So the final digit is your leaf. You do have to order your leaves from smallest to largest, your stems from smallest to largest, and your leaves from smallest to largest. So take a minute, jot these instructions down on how to make a stem plot, and then I want you to attempt the problem at the bottom. So now that you've got it drawn, take a look at how I would go through these steps. The first thing I do is list my stems. So the smallest tens value I have is a 1. The biggest tens value I have is a 5. Now, if I'm missing some of those numbers, let's say there's no numbers in the 20s, I still have to list the 2. I can't skip any of my stems. Then I'm going to list out all my leaves. The third step would be to put the leaves in order from smallest to largest. Don't leave your answer like that. You need to order them. And then the last step would be to provide a key. All right? You're not going to get full credit unless you have the key. So this says that 4/9 represents a female student who reported having 49 pairs of shoes. It always has to be in the context of the problem. You can't just say 4/9 equals 49. You have to relate it back to the problem. So the third type is a histogram. These are very commonly used when displaying quantitative data. So you do need to divide up your data into equal widths. So in the example at the bottom, it already tells you you've got 0 to 5 and then 5 to 10, 10 to 15. You can make it as wide or as small as you want to. Sometimes you may have to adjust it. If you pick a width of 5 and it doesn't display the graph very nicely, then you may have to change your width after that. So take a minute and see if you can draw the histogram using those 3 steps. Let me scroll so you can see the bottom of the data. There we go. All right, so go ahead and pause it. All right, so now that you've done your histogram, let me show you what mine looks like. I've got an X and a Y axis. I've got it labeled at the bottom. That's the percent of foreign-born residents. And then the left side, sorry, my computer's acting up. The left side is the counts. So we're counting how many states fall in that category. So in the 0 to 5 category, there's 20. So I draw my bar all the way up to 20. In the 5 to 10 category, there's 13. 10 to 15 is 9. 15 to 20 is 5. Then we have 2, and then 1. Notice the difference in this and a bar graph. My bars touch. I have numbers on the bottom, and I have numbers on the side. In a bar graph, I only have numbers on the side, and then I have the categorical variable at the bottom. So because my variable is quantitative, I've got numbers on both sides. I do have it labeled. Remember, you don't necessarily need a title for the whole entire graph, but you do need to make sure you label each axis. So the next thing we're going to talk about is how we describe the distribution of a quantitative variable. So what do I see once I make these graphs? So anytime you're asked to describe a distribution of a quantitative variable, you're going to talk about the shape, center, and spread. If there's any outliers, then you can also throw that in as well. Sometimes it'll ask you specifically for the outliers. If it doesn't, and you just do shape, center, and spread, you can get full credit. But I would always throw the outliers in there just in case. The best way to record these things is the phrase, don't forget your socks. S is for shape, O is for outliers, C is for center, and the second S is for spread. So let's talk about each one of those just for a second so you know how to describe the shape, center, and spread. So for shape, you're going to look for rough symmetry or clear skewness. If you don't see obvious skewness, then you're just going to say it's roughly symmetric. It has to be very obviously skewed for you to actually state that. So for a symmetric distribution, the right and the left-hand sides look approximately the same. They're mirror images of each other. So this first one, it kind of is low on the left, it goes up in the middle, and then goes low on the right. It does not have to be exactly the same on the left or the right, just approximately the same. If it's skewed to the left, then it's going to be higher on the right side and a long tail on the left. If it's skewed on the right, it's going to have a high part on the right, on the left side, excuse me, and then a long tail to the right. So wherever the tail is, that's the direction it is skewed in. So that's how you would describe your shape. For center, you can either use your mean or your median. And in section 3, we're going to talk about when you choose which, but I'll just go ahead and give you a brief way to decide. If it's skewed or you have outliers, then you're going to want to use your median. If it's roughly symmetric, then you'll choose to use your mean. So median is for skewed or data that has outliers. Mean is if it's roughly symmetric. That's the best choice. For your spread, you can either use your range or your interquartile range. Again, if it's skewed or have outliers, you're probably going to use the interquartile range. If it doesn't, if it's roughly symmetric, then your range is okay. And we'll talk more about that in section 3. Then when you describe your outliers, you're going to list any departures from the overall pattern. And again, when we get in section 3, we'll actually calculate the outliers. For today, we're just going to kind of estimate the outliers just based on the pattern we see. So look at this first example. Take a minute and see if you can describe the shape, center, and spread on your own based on what I just described. So for the shape, go ahead and reveal this. I'm going to get all this out of the way. So this says the distribution is skewed to the left. Right there, that first sentence tells us the shape. Then the next part says the median is 28 miles per gallon. The second sentence tells us the center. The third sentence, the highest value is 33 miles per gallon and the lowest value is 14 miles per gallon. The range is 33 minus 14, which is 19 miles per gallon. So those two sentences together give us the spread. And then the last sentence, there are two mid-sized cars with unusually low mileage ratings, so they fall outside the pattern. So the Bentley and the Rolls-Royce are potential outliers. So I hit all four parts: shape, outliers, center, and spread. And so I have to get all of those to get full credit on the exam. So go ahead and pause the video, take a minute, and try the Check Your Understanding on page 31. So now that you've done it, this is what I've got. Number one was talking about the shape. It's skewed to the right. Number two, depending on which one you use, since it was skewed more than likely, hopefully you listened to what I said and you did the median. But if you didn't and you did the mean, that's okay too. So the median is 1.5, the mean is 1.75. The number of siblings varies from 0 to 6, therefore your range is 6. And there are two potential outliers, those students reporting 5 and 6 siblings. So now pause again, and I want you to go to page 41 and do the Check Your Understanding on that page. All right, so to do this histogram, I'm actually going to show you how to do it on the calculator. If you did it by hand, that's great. But from now on, the fastest way, I'm going to go ahead and tell you is at the calculator and then just to copy it from your calculator. So first thing you want to do is you want to type in your data. So you're going to hit Stat, and the button should light up on my calculator so you can see where that is. So there's the Stat button. And then you're going to Edit, so I'm going to hit Enter. And then L1, you're going to list all of your data. I've already done that. So if you want to pause the video and do it on your own calculator, that's fine, or you can just watch. So once I type that in, I'm going to go to second y equals. So this is stat plots. This is where I do all kinds of different graphical displays. So I'm going to hit enter on plot 1. First off, I want to turn it on. And then I'm going to go down, and I'm going to choose which type of graph. The first one is a scatter plot. We don't use the second one. The third one is our histogram. The fourth one is a box of whiskers, and we'll talk about that one tomorrow. So I'm going to highlight or hit enter on the histogram. XList, that's pretty much asking you where can I find the data. So we put our data in L1, so we don't need to change that. And how many times do you want to have the data on the graph? We only want it one time, so that's the frequency. So if I click graph, nothing's going to show up because this graph starts at -10 and goes to +10. But all of my data points are they're big. I think the lowest is somewhere in the 80s. So I need to change my window so that I can see my graph. So I'm going to go to Window. I can do my lowest as 80. My highest X value as 150 because my highest is somewhere in the 140s. And then the scale is how wide do you want the bars? I would say that you could go anywhere from 5 to 10 and it looks okay. So I'm gonna do mine as 10. And then I might need to change my Y minimum and maximum. I'm probably gonna have more than 10 in one bar, so let's just change it to 20. Then if I click my graph, I can see the whole thing. So from here, then I would just copy it onto my paper. If I wanted to see how high the bars are, then I would just click trace. And down here, n equals 3, that tells me how many fall in that category. So from 80 to 90, there are 3 in that category. Notice it says the minimum is 80, the max is 90. 90, if it is 90, it's not included in that bar, it's included in the next bar. So there's 3 in that bar, and if I click over, there's 4 in that bar. 14, 17, 11, 9, and 2. So now I can draw this on my paper. I would draw the X and Y axis. I would label this as IQ at the bottom, and frequency on the side. So maybe count it by 2, 2, 4, 6, 8, 10, 12, 14, 16, 18. So you may want to just label this so you know you're counting up by 2. And then my first bar is going to start at 80. And then since I already calculated or traced the calculator, I know how high each bar is going to be. So my histogram would look something like this. So the second part asks to describe the histogram. So it says the distribution is roughly symmetric and bell-shaped. There is my shape. The mean is approximately 115 and the median is 114. If you only said one of these, then you got your center. The IQs vary from 81 to 145, having a range of 64. That would be my spread. And there does not appear to be any outliers. So I got all 4 parts: shape, center, spread, and outliers. So the next thing I want to talk about is comparing distributions. So when I compare 2 different distributions, I still need to address all 4 parts: shape, center, spread, and outliers. So before you even start, I would go through and list each, all 4 parts for each one. So this is what I have. For South Africa, it's skewed to the right. For the United Kingdom, it's roughly symmetric. The center, South Africa is 6, the United Kingdom is 4. For my spread, my range is 23 for South Africa, 4 for the United Kingdom, and there are 2 potential outliers for South Africa and none for the United Kingdom. So that's a good list. However, if I asked to compare, that would not get me full credit. I actually have to make a statement as to if one's bigger than the other or one's smaller. So I'm going to have to take this information and put them into sentences that actually compare. So this at the bottom is what would get me full credit on the AP exam. And I'm not going to read it all to you. You can pause it if you like. One thing I want to talk about is your spread. If you say more variability, that's talking about your range. If you have a larger range in one, then that would have a more variability than the other. So take a second, pause it, read through these, and make sure you know how to make comparisons. So notice for the center, it says household sizes tended to be larger. So there's a comparison in that. Okay, more variability, that's my comparison. So make sure you're actually stating which one's bigger, which one's smaller when you're asked to compare. The next thing I want to talk about is stem plots again. So if you're asked to compare 2 different distributions, you may have a back-to-back stem plot. So your stems would be in the middle, and you would have the data for one variable on the left and for the other variable on the right. The other thing that's different about this, and this problem comes from the original example that we did on stem plots, we did the females, and this is what it looks like. Notice it was hard to find, to kind of see what the distribution was. It's very uniform. They're all about the same height except for the ones in the 40s. So sometimes it's best if we split the stems. So anything that would be, has a one place of 0 to 4, would go with the first one, and anything in the ones place from 5 to 9 would go with the second one. Same thing with the 2. 0 to 4s would go here, 5 to 9s would go here. So in that case, we split our stems so we could get a better idea of what the distribution looks like. So this would be the new stem plot for that same data. You still need your key as well for this. So go ahead and go to page 34. It's going to ask you to describe the distribution of the stem plots that we just did. It's going to ask you to compare those two. So here's the comparison that we have. It says, in general, it appears that females have more pairs of shoes than males. The median report for the males was 9, while the median for the females was 26. So here's the comparison, more pairs of shoes, and then it lists the information. It tells us that the males were 9 and the females were 26. So the second sentence alone would not be enough to get full credit. You have to actually have that first sentence that compares. The next sentence talks about the spread. It has a larger range. And then it tells us that one range is 44 and the other one's 34. That larger range part is most important there. You've got to make a comparison. Finally, both males and females have distributions that are skewed to the right. So we're saying that they are the same shape. And this right there should be although. Although the distribution for the males is more heavily skewed, as evidenced by the 3 likely outliers at 22, 35, and 38. The females do not have any likely outliers. And then the last 3 questions were multiple choice. They were all 3B. If you have questions about that, just kind of make yourself a note, and we can chat about that tomorrow in class. So that's it for section 3. You can email me with any questions or write them down, and we'll answer them in class. Thanks so much.